So, see here we have done AC circuit containing resistance only, inductor only, that is the pure inductor, and pure capacitor only. Now, here we are going to do the AC circuit which contains or which has resistor, inductor and capacitor, or you can say resistance, inductance and capacitance in series. So, all these three electrical components are connected in series, that is called also RLC circuit or LCR series circuit here. So, we have to see here what is the the total resistance offered by all these three components in AC circuit, and what is the phase angle or the phase difference between the current and the net EMF or the net potential difference. So, now see here in this case, suppose you have taken first here there is a resistor here or the resistance R, there is an inductor L and there is a capacitor C. All these three are connected to the AC source like this, and when the AC source is connected over here, so now the current is flowing through this. So, there is a potential difference across R, potential difference across L and potential difference across C. Now, what we can do here, in resistance we know it, suppose current I is going this side, so VR is also to this side. In inductor, if you are taking current to this side here, then potential difference, that is VL to upside, there is angle of 90 degree because voltage is ahead of current. Similarly, here in capacitor, if you are taking current I is over here and VC is to this side, there is a there is a phase difference between I and V, that is of the 90 degree. Here the voltage is lagging behind by current, here the voltage is ahead of the current, and here we can write here voltage is and current both are in the same phase. Now, we can draw a phasor diagram for this. When you are drawing the phasor diagram for this, it will be coming like this. Here we have taken x axis, this is the y axis and this is the origin. Here we take maximum value, that is the peak value of current I naught, and here also this side we can take VR. Here we can take VL to this side and VC to this side. Suppose we are taking VL is greater than VC, so obviously net voltage will be here the upside. So, the resultant will be somewhere in the first quadrant here in this case, and it is this side we can take here, this is O, this is A and this is B, and AB is representing here VL minus VC. And here we can take the maximum or the peak value of EMF here E naught. This is the phase angle we can take, that is called phi. Here this is the phase here. So, now we can calculate from this phasor diagram. Just if you see the triangle, this one is here OAB. In this case we can write in triangle OAB, we can write here OA square is equal to OB square plus AB square. Now, we can write here OA can be written here E naught square is equal to OB is here VR square plus VL minus VC, this is whole square. Now, we can solve. In this case, when we solve it, we will be getting, first we will writing the value of the voltages. So, maximum voltage across resistance can be written VR is equal to I naught R. Maximum voltage across inductor can be written VL is equal to I naught XL, and similarly across VC is equal to I naught XC. So, now we can write E naught square is equal to I naught R square plus, here we can write this, in this case is here I naught XL minus I naught XC whole square. We can take common I naught and we will be writing here I naught upon E naught upon I naught is equal to under root of R square plus XL minus XC whole square. This I naught upon E naught is known as Z, we write by Z, and that's value is here R square plus XL minus XC whole square. And this Z is known as, in this part here, this Z is called impedance. and its unit is here ohm only, because it is representing here the total resistance of the LCR circuit here. So, the total resistance offered by LCR circuit is equal to, that is Z is equal to under root of R square plus XL minus XC whole square. So, now this is the total resistance in case of the LCR circuit. Now, here in AC circuit we have calculated impedance. Now, let us see the phase angle. So, we have seen the phasor diagram for this, and this was here like this, that is a E naught, and this side this was VR, and this is phi and VL minus VC. So, we in LCR series circuit we can calculate this phase angle between the current, because the current is taken to this side, current and the voltage. So, the phase angle this tan phi can be written VL minus VC upon VR, and it can be also written here I naught XL minus I naught XC upon I naught R, and we can write XL minus XC upon R. Now, see here in this circuit, if you are taking suppose XL is equal to XC. So, if you have taken XL is equal to XC, then what happened? This phase, that is phi, is equal to 0. It means the circuit is non-inductive. And if you are taking suppose XL is greater than XC, so obviously when you are taking XL is greater than XC, then you will be getting XL is greater than XC here, you will be getting phi is positive. That means the circuit is inductive here, and because inductor or inductance is dominating here. So, that is called inductance dominated circuit if XL is greater than XC. If you have taken XC is less than XL is less than XC, then this is the circuit where is the capacitance is capacitor is dominating. So, capacitance dominated circuit is known as here if XL is less than XC. So, these are the phase angle here between the voltage and current in the LCR circuit. And also in the LCR circuit, see here there are the three components: resistor, inductor and capacitor. And we have seen in inductor, that is the maximum voltage is I naught R, in inductor it is I naught XL, and in a capacitor is that is I naught XC. And here in a resistor here, you know, V, I and R, so V and I both are in the same phase, whereas in inductor current is lagging behind by pi by 2, whereas in capacitor circuit current is ahead of the voltage by pi by 2 here. So, now here if we make all these resistances in a here circuit, so we can take this side here, suppose this is here the R, and this side we take here XL minus XC, and this triangle, I am representing everything in the triangle, this is the phi. So, this side is representing to you, this is Z. So, here we can write Z is equal to under root of R square plus XL minus XC whole square. So, this triangle is known as actually impedance triangle, and here we can write cos phi is equal to R by Z, and that this cos phi is known as here the power factor. So, this is about the impedance triangle and the power factor here. And also you know here the reciprocal of reactance is known as susceptance, and whereas the reciprocal of the the impedance is known as admittance. So, these are the quantities here which we can define or which we can discuss with the help of the LCR circuit.